How do we make AI explain itself? What does it mean to explain, to give your reasoning? What if reasoning itself could become visible, an operational substrate we can observe, manipulate, and reuse? In this presentation, I'll show how the principles behind GPS can be applied to chess, and what happens when reasoning itself becomes something we can map. What is reasoning? If it is reasonable, it is explainable if not self-evident. Think back when you were in elementary school doing math. You were told to show your work. You were expected to go step by step and reason out layer by layer until you arrived at a conclusion. What you were doing there was the first institutionalized idea of informally objectifying reasoning. What you are doing here is navigating through a reasoning space, going from square one to the final destination using reasoning. Are there other examples of objectifying reasoning? Absolutely. The GPS is an optimized reasoning space, one we take for granted every day. Think about it. Right now, I could open my phone here in Chicago, zoom out to Panama, and in seconds, I'd have a complete reasoning path, step by step, turn by turn, with time estimates, distance, and live feedback from millions of others. This is a public reasoning commons, a collective intelligence mapping of the world in real time. Yet this space, dynamic, vast, ever-changing, is far more complex than chess, and we navigate it effortlessly. Why? Because we objectified it. We created a self-referential object, a map, that lets us reason about reasoning itself. Once reasoning becomes an operational, self-referential substrate, combinatorial explosion collapses. A map is a contextual basis, a substrate for integrating understanding. It lets us explore, assemble, and reason across reality itself. But here's the paradox. The real world is vastly more complex than chess. In chess, the board is static, the rules are fixed, and the total number of possibilities is finite, yet we treat it as impossibly hard. Meanwhile, the real world is dynamic, construction zones, detours, weather, traffic, even accidents, changing conditions every second. And still, we can open our phones, get real-time optimized paths, and navigate this complexity effortlessly. That means we've already solved a reasoning problem's order of magnitudes harder than chess by objectifying it. We turned the combinatorial explosion of reality into a navigable reasoning space. Mapping reality, in this sense, is already a proof of concept that infinite reasoning spaces can be solved, not by brute force, but by self-reference and contextual grounding. Now that we've established that GPS already solves a reasoning space vastly more complex than chess, let's apply that same principle to a smaller, finite domain. Chess is static. Its rules never change and the board doesn't evolve. Every possible position can, in theory, be mapped. So if we can objectify reasoning in the real world, a dynamic, infinite reasoning space, then doing so in chess is far more tractable. We can think of chess as a compressed microcosm of the same GPS logic, a sandbox where every move, every pass game, every reasoning trajectory can be mapped into an objectified reasoning space. This insight here is that GPS is the proof of concept, chess is the test bed. Once we map reasoning itself, the game can be approached self-referentially, enabling understanding dominance of the reasoning space, just as GPS achieved navigation dominance of the physical world. Up to this point, we've seen that both GPS and chess operate within distinct reasoning spaces, but something fundamental is missing between them. GPS has a map, a structured, navigable model of the real world. Chess has a move tree, a structured model of possibilities. Yet neither of these systems share a universal reasoning substrate, a medium where reasoning itself can exist as a first-class, reusable object. If such a substrate existed, we could begin to transfer optimization principles across reasoning spaces. The same methods that help GPS find efficient paths through terrain could, in principle, help us find efficient reasoning routes through a chess position, or through any conceptual landscape. This is what compute once reasoning objects make possible. By objectifying reasoning, computing it once, and reusing it, we enable reasoning processes themselves to be mapped, compared, and optimized. Just as GPS fetches routes through a physical space, a reasoning substrate would fetch routes through a contextual space, dynamically adapting and recomputing as context evolves. That's the missing medium, a substrate that turns reasoning into something we can explore, navigate, and improve. Here's the breakthrough insight that follows naturally from that idea. If we can map and optimize navigation through the ever-changing real world, then we can map and optimize reasoning itself, even in something as complex as chess. The so-called combinatorial explosion isn't a law of nature. It's a symptom of unstructured reasoning. Once reasoning becomes objectified and self-referential, once it lives inside a navigable map, the barrier collapses. We can apply the same optimization principles that make GPS efficient to the reasoning landscape of chess. We stop replaying moves mechanically and instead start navigating reasoning paths intentionally, seeing how different reasoning routes intersect, diverge, and adapt. In this view, reasoning becomes a terrain, and intelligence becomes the art of navigating it. So how do we actually begin mapping a reasoning space like chess? It sounds abstract, but there's a practical, almost tangible way to approach it. Think about how we learn a new city. At first, we just follow directions, step by step, one route at a time. But as we drive, those fragmented directions start to merge in our mind, forming a coherent map of the space. Now imagine doing that with reasoning itself. Every recorded chess game, every move sequence, is like a route through reasoning space. By objectifying reasoning as a first-class entity, we can start to merge these countless linear trajectories into one integrated navigable reasoning space. Overlapping reasoning paths reinforce each other, rare routes reveal strategic shortcuts, and the entire reasoning landscape becomes visible, just like a GPS map of roads. Of course, unlike roads, the chess landscape is adversarial. The terrain fights back. Each opponent move shifts the local structure of the reasoning space, almost as if the streets themselves were moving against you. Yet the same optimization principles still apply. We can still seek the best route towards a target condition. We can still measure efficiency. We can still repath dynamically. And here's the deeper insight. Once we formalize reasoning as an object, we can train models not on fragmented samples of reasoning, but on the reasoning space itself, learning not just outcomes, but the structure of thought that led there. At that point, when the model navigates this space, its reasoning path and the map it traversed are both explicit. That's when explainability stops being an afterthought. It becomes self-evident. This isn't just a thought experiment or a proof of concept. It's an open initiative. We're building the foundations of a universal reasoning substrate, a framework where reasoning itself becomes a first-class computational object. And to do that, we need a dedicated language, a domain-specific language designed to encode, manipulate, and navigate reasoning itself. The OrganismCore project and the agents.md methodology are the first steps in that direction. They show that this isn't just possible, it's already beginning to work informally. Imagine if we had a way to optimize universal reasoning, a truly grounded, principles-first approach to general reasoning with explainability built in. So this is an invitation to researchers, to builders, to anyone who wants to help shape the next leap forward in explainable, self-referential AI. Together, we can formalize the language of reasoning, and with it, begin to truly navigate the space of thought itself. And perhaps most importantly, this is already happening. Every step we take towards objectifying reasoning brings us closer to a world where intelligence is not just powerful, but understandable and available to all.